Okay, so in this video we are going to talk about the parts of y of s, like I said in the previous video. Okay, just concluded video. So please do well to watch the videos in this playlist step by step, one after the other, because each one is the continuation of the previous. Okay, so yeah, we stopped at this part in the last video and I said y of s or y of t, which is the time domain of y of t, has two parts. Okay, it has two parts. This, note that a signal can be seen to have two parts. A signal can be seen to have two parts. The part that depends on initial condition, which is this part depends on initial condition. That means what is the value, or what do we have before receiving an input? What do we have, as in what's going on before we receive the input? Okay, so that's the initial condition, and the part that is due to input, which is this other part. Now, the main difference between these two parts, is that this one does not depend on input. This part exists without the input. That's before input, initial condition. Now initial. Then for this part, it is the part due to input. After receiving input signal, this part is due to input signal. Now most of the times the initial conditions are zero. In fact, when taking Laplace transform, most times we assume initial conditions to be zero. Okay, so y of 0 equals 0. That's most times we assume that in Laplace transform. So just bear in mind that the two parts that make up the y of t. Okay, now, okay, here we just defined them, saying that yzi of t is the part that depends on the initial is the part that depends on the initial, let me take out this guy, initial condition, and it's called zero input response. Makes sense. Zero input. What's the input at that time? Zero. No input. Okay, zero input response. Then the other part, yzs of t, is the part due to input signal x of t, and it's called zero state response. Okay, zero input response, zero state response. So for our y of t in the equation above, we have this guy. Now look at this. This is our y of s, which this is our y of s, which can be regarded as y of t in time domain. Okay, so this is in frequency domain, y of s. In time domain is y of t. Okay, so you can see these two parts. Part 1, let me even use a different color. Part 1 and then part 2. Okay, now we can see that this part has the x of s, so meaning this part depends on the input, and this part depends on the initial condition. Yeah, you can see, let me zoom out if you can see that clearly, and I hope you can. Alright, so you can see it clearly. Okay, so that means yz of s, which is this zero state, is this exactly what we have here. And then this other part, which is this, is what this we have here. Okay, now recall that h of s is y of s over x. Let me can zoom in now. So the transfer function is output signal over input signal. Okay, which is this. Now, to get the transfer function of a system, we assume initial conditions to be zero. I think I said that. So that means this y of t, which is the inputs, the zero inputs and zero states, which are this part depend on initial condition. So we assume it to be zero. That means everything here will be zero, and then we'll have this guy left. So that is y of s. This part we have here, 0. So we'll be left with this. That means we'll now have y of s equals just this part right here. And then when you divide both sides by x of s, this comes down, x of s comes down, and this is our transfer function. So the transfer function of our differential equation that was given equals to these guys here. That's it. Okay, we've gotten the transfer function by taking the Laplace and by taking the Laplace transform of that differential equation. So if we want to completely solve to the point where we have y of t, if you want to completely solve to this point, all you have to do is to substitute in the coefficients if they are given. Oh boy. If they are given. Alright. So if the coefficients are given, when I say coefficients, I mean these guys. What is a1? What is a0? What is b1? They are numbers, okay, real numbers. But in this case, we just use letters. So we are not going to continue the solving. We'll stop here. But if we have the coefficients, we'll continue the solving by substituting in the coefficients, and then we carry out partial fraction expansion. Then we take the Laplace inverse. That's all. We'll get y of t. Okay, we'll get y of t. So we'll stop here in this video, and in the next one we'll talk about some properties of this transfer function, because understanding this property of transfer function will help us to carry out some operations, and we'll also talk about partial fraction expansion too. So I'll just stop this here, and yeah, I'll stop this here. Okay, so pause the video, take it back, watch again and again, and then comment. Okay, and it's nice if you comment on a particular video where you have an issue, so that I'll just see the comment and then know that this comment is based on this video, and then check and give a reply. Okay, so like, share, subscribe, and thanks a lot for watching, and I'll see you in the next video. Bye for now.